Okay, so in this lesson, we're going to look at sum, difference, and double angle identities. It's a good idea to have these familiarized. If you notice the pattern here, where you've got sine alpha minus beta, you've got sine alpha cos beta minus cos alpha sine beta. So what happens is you've got a sine and then a cos, and then you've got a minus, cos, and then sine. And your alpha and betas kind of stay in the position that they are. For cos, you've got cos, cos, sine, sine, and a plus. And this is the identity for tan, alpha minus beta. And then here you've got tan alpha minus tan beta all over 1 plus tan alpha times tan beta. And then here, this changes to a plus from the minus up here, and then we've got pretty much, let's see, sine, cos, alpha beta here, and then a plus cos alpha beta here, okay? You've got a sine, cos, sine. And then for cos alpha plus beta, you've got cos, cos minus sine, sine. And for tan alpha plus beta, you've got tan alpha plus tan beta all over 1 minus tan alpha tan beta. So pretty much the difference from here and here is the signs are switched. All right, so now you've got double angle identities, which is right there. You see how it says 2 alpha? That's the double angle. And that is the same as 2 times sine alpha cos alpha. And then there's 3 different ones for cos 2 alpha. There's cos squared alpha minus sine squared alpha, 1 minus 2 sine squared alpha, 2 times cos squared alpha minus 1, and then your tan 2 alpha, you've got 2 tan alpha, 1 minus tan squared alpha. All right, so now if we're looking at A, okay, before anyone moves on, there's a typo here. This should be pi by 6. Not 8, no, because we're going to use the exact values, okay? So that should be pi by 6. That's just a typo there. Now, let's look at this, A. Which identity does this look familiar to, where you've got cos, cos plus sine, sine? So you want to find the same pattern up here. So you've got, think of this as your alpha. Think of that as your beta, alpha, beta. You notice how we'll let pi by 3 be the alpha and pi by 12 be the beta. So which one looks like cos alpha, cos beta plus sine alpha, sine beta? So where's that one? That's over here? All right, so that's cos alpha minus beta. All right, so how are we actually going to use this? Well, instead of putting the pi by 3 and the pi by 12 here, what do you think we're going to do? Put the pi by 3 here and the pi by 12. So we can rewrite this as cos pi by 3 minus pi by 12. Now figure out the figure out this part. So what does that equal? We need a common denominator. So what's our common denominator here? 12, so that's 4 pi minus all over 12, right? We're multiplying this by 4 and this by 4. So then I get cos 3 pi over 12, which is, I wish I had more room so that I could work down instead of across. Cos 3 pi by 12, which is cos pi by 4. What's cos of pi by 4? So it's root 2 over 2. So the answer to A is root 2 over 2. Okay. Now, if we're looking at B, it's not a special angle or an exact value right here. It's cos squared of 47 degrees and plus sine squared of 47 degrees. Well, what do you notice about the identities? What identity could we replace here? If I just had a theta here and I had a theta here, what would you notice? You've got cos squared theta plus sine squared theta, yeah, equals 1. So what is the answer to 1? What is the answer to B? 1. All right. And then let's have a look at this one. Which identity does this look similar to? So I have a 1 minus 2 sine squared, and let's call that pi by 6 alpha. So that is the same as right up here. You see that? So then I've got cos 2, and then instead of alpha, this was pi by 6, right? Yeah. So what am I going to replace here? Pi by 6. Use cos 2 alpha. Okay, so let's evaluate that. What's cos 2 alpha? This together is 2 pi by 6, which reduces to cos of pi by 3. And what's cos of pi by 3? Cos of pi by 6 is 60 degrees, right? That's 1/2. All right. So you see how we're using the identities to make it easier to evaluate, and then we do the evaluation. Okay. All right, so now this next question. We can use these formulas to determine the exact value of a trig ratio that is not on the unit circle. So now 7 pi by 12, that's not one of the ones that we know, right? It's not a 0, 30, 45, 60, 90, 180. It's not one of those multiples. So what we need to do is we need to take this and we need to somehow break it up so that it is a combination of those special angles. So we have to do a little bit of investigative work or break it up somehow into something that can be reduced. If we look at 7 pi by 12, what denominators do we want to end up with? Yeah, so we want to end up with either something with a 2, a 4, or a 3, right? So the easiest one that comes to mind, so I could either break it up as 1 and 6, the 7 pi as 1 and 6. There's different options. So I could look at it as 2 pi and 5 pi over 12, right? I could look at it as 3 pi plus 4 pi over 12. Do you see what I'm doing? All I'm doing is I'm breaking up the numerator so that I can see what's going to reduce nicely. So both of these can be reduced fairly nicely. So what is this part going to reduce to? So sine 7 pi by 12, I can rewrite it as sine 3 pi plus 4 pi, and both of those are over 12. So that reduces to sine of I've got pi over 4 and pi over 3. All right, are both of those going to give me exact values? Yeah? All right. So now, which identity is sine pi, sine angle plus another angle look like? So so I'm going to look back here, and which one does it match with? Is this one right here? Yes. All right. So this is the one I'm going to use. So let's write that down. So I've got sine, it's my alpha plus beta. So I've got sine alpha cos beta plus cos alpha sine beta. Now what are we going to call alpha? What are we going to call beta? Okay, so this is going to be pi over 4, and this is going to be pi over 3. Keep it organized. If you're starting to mix things up, it's just going to get confusing. If you were to have it the other way, pi by 3 plus pi by 4, then you would just have everything in the opposite order here. Okay? Just make sure you're being consistent with what you're working with. So this is pi by 4, and this is sine of pi by 3. Right, now we need to solve this side. We're just going to be working, because really what this is sine pi by 4 plus pi by 3. So now we're just plugging in the values. Yeah, so now we're going to use our exact values. So what's the value of sine of pi by 4? Root 2 over 2. Okay, what's the value of cos of pi by 3? What's the value of cos of pi by 4? Root 2 over 2. And what is the value of sine of pi by 3? That's root 3 over 2. Okay, see how we took everything, we broke it up into simpler pieces. Even though it's longer, the individual pieces that we're working with are much simpler to deal with. So now I could just take these values and multiply them together, which gives me root 2 over 4, and these two multiplied together gives me root 6 over 4, and then I've got a common denominator already, so I just need to add the numerators, and I get root 2 plus root 6 over 4, and that's my answer. So this is my final answer. That's simplified, my denominator's rationalized, everything is fine. Okay, now, part B says cos of 195. What do you think we're going to do with the 195? Let's stay in degrees. Let's stay in degrees and just do the same idea. So we need to break up this angle so that it's nice numbers that we can deal with. Well, we know since this is a 5 that one of the angles must be 45 degrees because we have that 5 there. So if I choose 195, if I choose one of them to be 45 degrees, what could the other one be? 150. All right. So I've broken it up into two values that I could get exact numbers for, so I'm just going to work with these. All right. Since I have cos 195, and I've broken it up into cos of 45 degrees plus 150 degrees. Which identity am I going to use because I have that plus there? So I'm going to use this one right here. Right? Okay. So let's copy that one down so we know what we're working with. Cos alpha, cos beta minus sine alpha, sine beta. All right, so here we've got cos of 45 degrees plus 150 degrees equals cos 45 cos 150 minus sine of 45 and sine of 150. Okay, so what is cos of 45 degrees? Root 2 over 2. Okay, what about cos of 150? Cos of 150 is which quadrant? Quadrant 2. So it's going to be negative. Okay, and then how about sine of 45? Okay, and then sine of 150. It's positive. It's in the second quadrant. It's 1/2. All right, so now I'm going to take these two, multiply them together. These two, multiply them together. So for this first part, I get negative root 6 over 4 minus root 2 over 4. And what is my answer? Negative root 6 minus root 2 over 4. So break it up into two angles that are easy to work with, and then substitute it, evaluate it, and simplify. Okay. All right, so the next question says, we can simplify expressions using identities.
Sorry.
All right, so now here we've got 1 minus cos 2 theta over sine 2 theta. So it says here, determine the non-permissible values for this expression. Okay, so do you remember what non-permissible values are? Yeah, what are they? All right, so we can't let sine 2 theta equal 0. All right, now what is sine 2 theta? Well, let's look at our identities and see if we can find an expression that, yeah, so it's right here. All right, so sine 2 theta I can rewrite as 2 sine alpha cos alpha. Wait, why am I writing alpha? I'm writing alpha because that's what's on my formula sheet, but I should be writing theta. That would be a technical foul if you guys change your variables in the middle of a question, right? If you get two technicals, then yeah, geez, you're out. Okay. No, that would be a loss of a half mark. Okay. All right, so now, really, I could just simplify this to say sine theta cos theta cannot equal 0, which means if either one of these factors, if this equals 0 or if that equals 0, then that's going to create this whole thing to be 0. So let's find where sine theta is not allowed to be 0, so what is theta not allowed to be? 0, pi, or 2 pi. Okay, and to just put a finish to this question or put an end, let's just put in a domain here so that it's between 0 and 2 pi, and let's include the 2 endpoints. Okay, just so that I don't continue on forever having to answer this question. So cos theta can't be 0. Where is that? Where is cos theta 0? Pi by 2 and 3 pi by 2. All right, perfect. Now, those are all my non-permissibles. So these guys and those guys. Theta is not allowed to be those. Part B, simplify the expression to one of the 3 primary trigonometric functions. So that means you're going to simplify this (1 minus cos 2 theta over sine 2 theta), and you're going to simplify it until you get to either sine, cos, or tan. So 1 minus cos 2 theta, let's look to see if we can find that on our, right here. So I don't have a 1 minus cos 2 theta, but what I do have is I have a cos 2 theta. So can I take that and replace that part of it with one of these? Well, there's 3 of them. Hang on. There's 3 of them. Which one would simplify nicely? You know what? What do I notice? Let's use this middle one. This top one's a little complicated. The bottom one, it's meh. I don't know. How do you guys feel? You guys feeling the second one? It doesn't really matter. No. Okay, I'm feeling the second one. 1 minus 2 sine squared theta. Okay. And that's going to be over sine 2 theta. All right, so I used the second one to replace this cos 2 theta with. Okay, 1 minus 1 plus, so this multiplies through, over, let's replace the sine 2 theta with something. Let's replace the sine 2 theta with, what can we replace the sine 2 theta with? Right here? There's really only one option. 2 sine theta cos theta. All right. So now let's simplify things. These 2 are equal to 0. And then I've got 2 sine squared theta over 2 sine theta cos theta. So this 2 and this 2 reduce to 1. And then I've got a sine squared on the top and a sine in the denominator. So one of them cancels out on the top. So then I'm left with sine theta over cos theta. So then that equals to tan theta. Is that exciting? It's exciting stuff, hey? It's kind of cool how you could morph one thing into the other. It's like transformations, more than meets the eye. Good times. Good times. Or should I say transformations? Oh, so funny it hurts. Okay. Maybe it just hurts. Okay. Okay, so example 4. If cos alpha equals -4/5, where pi by 2, where alpha is in between pi by 2 and pi, what is that referring to? The second quadrant? So that's between here. Here and here, right? And cos beta is equal to -12/3, where beta is between pi and 3 pi by 2. So what is that referring to? Okay, so this is quadrant 2. This here is between here, quadrant 3. I should make 3 lines for 3. Okay, so I need to figure out cos alpha minus beta. Okay, so what does this tell us here? What information do we get from here? We get the adjacent and the hypotenuse, right? So here, let's find our alpha triangle. So we can look at this part. It's in the second quadrant. I've got 5 as my hypotenuse, and it's going to be a 3, 4, 5 triangle. My -4, see, this is my hypotenuse. That's my adjacent. And this is my 3, 4, 5 triangle, so I know that's going to be 3. Now, if I wanted to figure it out, if it wasn't a Pythagorean triple, you guys know what Pythagorean triples are? They're triples of Pythagorean. Yeah. Good job. All right, so I can figure it out just using this. And then I got b equals plus or minus 3. But how do I know that I only need to talk about the positive 3 here? Because I'm in the second quadrant and my height is 3 up for the second quadrant. Okay. Now, how am I going to deal with this part here? So what is cos? What does this give me here? I know it's going to be in this third quadrant. So where is what about my beta triangle? My beta triangle. So this is my adjacent, and this is my hypotenuse. So this is 13. It is. You should be enthusiastic about it. It's so exciting. So I'm going to have my -12 here. And what is this going to be? This is another Pythagorean triple, I think. Okay, let's work it out. So -12 plus b squared, 13 squared. And then I get b squared equals 169 minus 144. And b is, this is going to be 25. Square root of 25 is 5. And it's negative. Why is it negative? Because I'm in quadrant 3 and I'm going down 5 units on my y-axis. Okay? So there's so many different ways that you could look at it. But as long as you get to the same place, that's what's good. Okay? All right. Now, I need to figure out what cos alpha minus beta is. All right. So which identity does this give us? This gives us, so look back on your sheet. Go back and find it. Where do we find it? Second one from the top. Okay, so it is cos alpha, cos beta, plus sine alpha and sine beta. Okay, so now I somehow have to use all this information to figure this out. Well, what do I have so far? I have cos alpha and I have cos beta, right? What is cos alpha? I can just look up here, and it's minus 4 over 5. And what's cos beta? That's right there. So that is negative 12 over 13. But then all of a sudden, there's this sine alpha and sine beta. Well, I don't have that anywhere on my paper, so what do I do? So I use the y over r, and what does that tell me? So sine, so here, let's kind of use this space in the middle. So sine alpha, what is sine alpha going to be? So I'm going to use this information here to give me sine alpha. Okay, so what is it going to be? What is my y was 3, and then what about my denominator here? What was my r value? 5. Okay, and then I also need sine beta. Where do I get sine beta from? So let's use the beta triangle. Okay, so what's in the numerator? So what's the y value here? Negative 5, and then my r is over 13. Ta-da! So now I've made my sine alpha and sine beta. That was the whole purpose of this triangle business that we did. Okay? That was the whole purpose of that triangle business. So now sine alpha is 3 over 5. Sine beta is negative 5 over 13. And multiply it together, do the hokey pokey, and turn yourself around. So what is it all over? What's 13 times 5? Okay, and 33 over 65. So that's our answer. So that's what cos alpha minus beta equal. Okay? So here, use what you have to figure out what you need. No, we can't reduce that. Okay. One more page, and then you get to work on your homework. Okay. Yay. All right, so if theta is between 0 and pi by 2, and sine theta is 3 over 5, determine the exact values of okay, sine 2 theta. All right, so now let's try this. Yeah. Okay, so what are we going to do now? Here, what quadrant are we working in? The first one. So I've got this is what triangle is this? This is r, this is y. So what is x? X is? Okay. So x is 4. Go up. That's 3, and that's 5. I'm working in the first quadrant. Where's theta? Theta's right there. That's my reference angle. Okay, determine the sine of 2 theta. So, what identity do we know that we could use here?
2 sine theta cos theta.
I lost my sheet. Okay, where's my... Okay, sine 2 theta. That's here? This one? Okay. So I can use 2 sine theta cos theta. All right, and what do we need in order to do this? So, do we have sine theta already? Yeah? Okay, 2 and then 3 over 5. And then how do we know what cos theta is? Why is cos theta 4 over 5? Okay, so, and then what? Multiply. So we get?
24 over 25.
That's it?
Yes.
Okay, next question. Cos 2 theta. All right, so which identity are we going to use?
Use the first one.
Well, if we use the second one, if we use this one, I don't really have to figure anything out much, right? I can just use what I'm given, and then I've got 3 over 5, and I can square that. Do you see the rationale behind that? If I just treated them as 2 separate, completely separate questions, I wouldn't have to figure out anything extra if I just use this one, because I'm given sine theta equals 3 over 5 here. If you do the other one, if you do the other one, if you use one of the other identities and do use what we found for cos, it should work out the same. 1 minus 18 over 25. 25 minus 18 over 25 equals 7 over 25. All right. So it's handy if you are familiar with some of the Pythagorean triples. So if you want, you can look them up when you're bored. It will entertain you for hours and hours. Okay. So there's the homework at the bottom of the page there. Make sure you do practice questions, because practice makes perfect. All right, thanks for coming out.